Alrighty, I think this is working. I hope so. We'll see. We'll see if it works. All right, so this is the remainder of the lesson that you guys did not get just because we ran out of time today. The first thing is when we want to find angles of lines that intersect outside of a circle. So basically, if you have something that looks like this situation here, okay? So we want to figure out the measure of angle B. In order to do that, we're going to subtract the two arc measures and divide by 2 or multiply by a half. So to find this angle, and this would be something you guys want to write down, to find this angle, we take half of arc AD minus arc AC. Okay, so the bigger arc minus the smaller arc there. So in this example, we want to find the measure of angle B. So in order to do that, I'm going to say the measure of angle B, or you could say x equals, whatever. We're going to take, I like, instead of multiplying by half, I like to divide by 2. So another way to write this relationship is the measure of AD minus the measure of AC, and then divide everything by 2. That's what I like to do. So I'm going to take 100, which is the arc on the outside, the big arc, minus the arc on the inside, and then divide by 2. So we end up with 70 divided by 2, which is 35 degrees. Okay, so it's just a matter of knowing that formula and when they're asking you to find something like that. And that's tricky. It surely is. Okay, this one is a little crazy because we got to do a few things. First thing we're going to do, if we want to find x, we need to know that relationship, the measure of that angle. So we'll just say, I don't know, we can call it B. The measure of angle B is equal to the big arc minus the small arc, and then divide by 2. So we know the measure of angle B, that's 60. The big arc is 190, and we don't know the measure of the small arc, and then divide by 2. So in order to solve that, I'm going to multiply both sides by 2. So I get 120 equals 190 minus x. Then I'm going to subtract that 190. We get negative 6, no, can't hit 70, right? Yeah. 120 minus 190. Yep, 70. We get negative 70 equals negative x. Then you're going to divide by that negative 1. That leaves you with 70 equals x. So this arc measure is 70. Now we have to figure out this angle y, that actual tangent angle. And we studied that relationship last class. So I'm just going to pull up our notes here because, of course, I forgot the relationship. Bad Jen. But that is something that we studied last time. We're going to need that arc measure that we're missing. I'm just going to find the relationship. That's the tough thing about all of these. Oh, it's an angle right on a circle. Yeah, that's right. That's an inscribed angle. If it's got its vertex on the circle, it's half the measure of the intercepted arc. Okay, so that's what we would do. So we need to figure out this measure, this arc measure right there. And we already know that this part is 190 and this part is 70. So if I wanted to figure out that missing part, I would just go 360 minus 190 minus 70. So that leaves me with 100. So this is 100, the arc is. Now, if I want to find the measure of the angle right on the circle, all I have to do is take half of that arc measure, because this is an inscribed angle. That relationship that we said last time is if we have a circle and if we have an angle right on the circle, even if, I believe it was a slide I showed you right before we logged off. Yeah, the special case. Even if one side of the angles is a tangent line, the same property applies. It's still half the measure of that arc. So y would be half of that arc, which is 50. And degrees. Good. We're cruising. Okay, a chord, you guys know, a chord is a segment connecting any 2 points on a circle to any one point to another point. So it goes through 2 points on the circle and does not go through the middle. There are a lot of properties of chords. So we'll kind of just highlight the important ones here. So here, this one is congruent angles and arcs. Basically, it's saying if you have two angles that are congruent, two central angles that are congruent, it means the arcs are congruent as well. And then vice versa. If you have two arcs that are congruent, the angles are congruent. This one tells us if you have, it's kind of the same deal. If you have two central angles that are congruent, then the chord that is made when you connect them is also congruent. So basically, if when in all these circles, if one side's congruent, the other one is as well. And then congruent arcs equal congruent chords. That's what this is saying. If you have two chords that are congruent, the arcs are also congruent. This is my Epic pen, by the way. This is something you guys can download. It's pretty cool. Okay, so in this one, if the measure of arc CD is 45, what is the measure of arc AB? So this one is using that property. Remember, we have a central angle here, okay? That means angle 1, since it's a central angle, is going to be whatever that arc measure is. So it's going to be 45. And then angle 2, check it out. Angle 2 is a vertical angle. So that would also be 45. Oh, and then it's another central angle, which goes right to the measure of arc AB. That would also be 45. So lots of just kind of guessing what's the same there. And then I could figure out 3 and 4. We could subtract from 180 to find this angle, and then that would help us realize that these chords are congruent. Okay. Another property with chords is two chords in the same circle are the same distance away from the center if they have the same length. So if the segment that connects the chord to the center is the same as another one, then the chords are congruent. That kind of makes sense. You know, they have to be the same distance away for them to be the same. So in this one, we can see that we have two chords because they connect from one point to another, and then one point to another. And they are the same distance away from the center of that circle. So these chords are the same. So if I wanted to find x, I would just go 6x minus 7 equals 35. I would set them equal to one another. Then I would add 7. That gives me 6x equals 35 plus 7, which is 42. I then divide by 6, and I get x is equal to 7. All right, this one's kind of the same deal. It's all about reading your figure and trying to figure out what they want. That's it. They want to know the length of RS in this. So I know quite a few things here. I know these chords are the same distance away from the center. So they're going to be completely the same. And I know this one's 12.5. That means this one's 12.5. So if I were to add those together, I'd get 25. And that tells me that this chord would be exactly the same as this chord. So SR would be 25. So it's all about reading the figure. You can't just look at it and know what it is. You got to make sense of what's going on and then answer it from there. By the way, my babies are sleeping on the couch. They're so cute. Guys, I can't believe this actually happened. It's a good day. All right, anyway. So now we have a diameter and chords. That's what this is dealing with, diameter and chords. Okay, and this diameter, it's saying would always be perpendicular if you have a diameter and it's perpendicular with a chord, then it splits that chord in half, and it also splits that arc in half. That's what it's saying. If you have a diameter, so AB is a diameter, and it's perpendicular with a chord, then that chord is split in half or bisected, and it bisects the arc too. Same deal here. If you have a diameter and it actually splits that chord, then it means it's perpendicular. So it has to be perpendicular for it to cut it in half like that. Okay, and this one's kind of saying if you have a perpendicular bisector, then it means it's a diameter. So in this one, what is the value of each variable? This one we're going to look for triangles. That's it. So in part A, I have a chord, and check it out. It looks like this part is a perpendicular bisector. So it's on that radius a little bit. So because it's a perpendicular bisector, and I know that because it makes that right angle, then we can split this chord in half, and we can say this is 7 and this is 7. And then it's just using my Pythagorean theorem. We have a right triangle here. So that tells me I can take my leg squared plus my other leg squared and set it equal to my hypotenuse squared, or as one of our students' mothers says, hippopotamus squared. There's a test if she's listening. So we take our leg squared plus the other leg squared, and that equals the hippopotamus squared. I'm just kidding, hypotenuse squared. So we've got 49 plus 9 equals the radius squared, or r squared, which is the radius. Beautiful. So 49 plus 9 gives us 58. And then we're going to take the square root of that. And that gives me, they want it to the nearest tenth. That gives me 7.6 is my radius. Yay! Hi, buddy. My son's waking up. The other one's the same way. Okay, the other one, we know we have a radius here. We got to try and make that triangle. Okay, so we have, it looks like it cuts the chord in half because both sides are 11. So we assume it makes a right triangle because that means it's a perpendicular bisector according to those theories. And if this is 15, then this is also 15 because it goes from the center to the side of the circle. And then again, it's another Pythagorean theorem. We're going 11 squared plus y squared equals 15 squared. And this is B. So we get 121 plus y squared equals 225. We're going to subtract that 121. We can solve for that y squared. We get y squared is 104. Get rid of that square root. Whoops, that's not the right button. And we get 10.2. And that would be my y value there. So again, it's just making a bunch of triangles. That's what you're trying to do. This one's a little crazy. And you know what? I just realized I forgot to write down what we're supposed to do with this one. So we're going to ignore this one here. My bad. All right. You will have a question come up that talks about how do you find the center of a circle? Okay. So all you need to know are these steps. This is what you need for this question for the homework. How to find the center of a circle and the length of the radius. Okay, so you're going to draw two chords in a circle. That's the first step. So for your notes, I would write finding the center of a given circle. Then I would write number 1, draw two chords, not parallel. Step 2, construct the perpendicular bisector of each chord. So see how we cut it right in half? And then step 3, the center is located where those perpendicular bisectors intersect. Pretty cool. So these are the 3 steps you need to have for your homework. All right, we are almost done. Now we're getting into circumference. And this stuff, you know, it's just formulas, that's all. So the formula for circumference is pi times the diameter, or 2 times pi times radius. And remember, pi is that number that is, I think it's circumference. I forgot what it is. Guys, how can I forget what pi is? What is pi? Yeah, I know it's 3.14. Okay, it's the ratio of the circumference to the diameter. So when you take the circumference of a circle and divide it by its diameter, you'll always get pi. It's pretty cool. So stands for the number 3.14159, something like that. So we don't want to use this number. What you want to do when you're calculating with pi is leave pi in there until the end and then round it, or go into Desmos and use the pi key. It's way more accurate. But never, ever, ever should we put in 3.14 because it's not what pi is. Pi is this crazy irrational number, and we want to keep it that way. So this one talks about concentric circles, and I didn't know if they would use that word in the homework, so I just wanted to make sure we talked about it. Concentric circles is a circle inside another circle, okay? So what they want is they're saying we have a 6-inch diameter drill blade and a 5 1/4-inch diameter hole. We want to find the difference between the outer and inner circumferences. So we're just going to find the circumference twice and then subtract it. That's all it means. So for this circumference, we're going to take 6 times pi minus 5.25 pi. And you might be asking yourself, because those are the two circumferences, that's pi times diameter, or diameter times pi, whatever. And you might be saying, well, Jen, can't I just subtract them? Yes, you can. Yes, you can. You can go 5.25 or 6 minus 5.25 and you'll get 0.75 pi. That would be your exact answer. Or if you multiply it by that pi key, you get 2.36, you would say, and it's inches. That would be the difference in there. But pi is kind of cool. You can almost treat it like a variable right until the very end. Okay, now we have to talk about arc length. So they might ask you to find the arc length, the length of an arc. So not the arc measure. This is different. We're measuring it compared to, oh man, it gets real tricky, but let's see. Think of a better way to say it. So I'm Googling actually, difference between arc length and arc measure. Okay, arc measure is degree measurement. Okay, so it is kind of tricky there. Arc length is the fraction of the circumference of a circle and calculated that way. Okay, so arc length is what fraction of the circle's circumference that is. So a circle's circumference is the distance around a circle. And if we're going to find arc length, we're going to find what fraction of that circle we're taking up there. Hi, Lizzie Bear. Uh-oh, she just woke up and freaked out a little bit. It's okay. It's okay. Come here. Someone had a freaky dream. Oh, baby. It's okay. So what you guys are going to do is you're going to, it's all right. It's okay. Is you're going to write down this formula. You're going to take the arc measure and divide that by 360, and then you're going to multiply it by the circumference of the circle. That's what you do. It's all right. Oh my goodness. So this one, they want to find the length of each arc shown in red. Okay, so we want to find the length of this arc. So we first need the arc measure. And we know arc measure is the same as that central angle. It looks like my central angle has that box. So that means it's 90 degrees. It's okay, Lizzie. So I think, yeah, you're all right. I think, oh my goodness, I think we had a bad dream. So we're going to take 90, which is my arc measure, and divide it by 360. And we're going to multiply that by my circumference. Oh, baby. Oh, goodness. We're almost done. Otherwise, I'd hit pause or something. So the circumference is going to be pi times the diameter. In this case, I'm given a diameter. So I'm just going to go pi times 16. And then I'm going to go from there. And we want to leave our answers in terms of pi. So we're going to go 90 divided by 360, and we like to use Desmos. I recommend using Desmos because it would very quickly tell you that this is the same as 1/4 times pi times 16. And 1/4 times 16 is the same as 16 divided by 4, which is just 4. So my answer is 4 pi. Yeah, baby, what's the matter? I know, I'm almost done, almost done. So this arc length would be 4 pi. Let's do the other one real quick here. So for this one, I want to find the arc length, or the fraction of the circle's circumference, okay? So, and just to put it in measurement here, the whole circle circumference would be 16 pi. This little part is basically 1/4 of the circle, so it's just 4 pi. So it kind of makes sense when you think about it. It's like cutting a pizza, right? Yeah, baby. Do you want the iPad? Yeah. Gotta remember I put that iPad. Oh, I think I put it on the counter. Can you go grab it for me? It's right over there, babes. Right there. Yeah. Your mama turned it on for you. Oh my. Okay. Okay. Sorry, guys. Snow days. Yay! Okay. Last one. We're going to take this arc measure, which is 240, as a fraction of 360. So there's the degree part. And we're going to multiply. Now we have a radius, so I could either double it and say it's 30 pi, or I could go 2 pi r. I'll just write it, you know. So 240 over 360. Again, I would use Desmos and type it in because they totally help you. This is 2/3. And this right here, 2 times 15 is 30. And this, remember, when you multiply a fraction by a whole number, you just put it over 1. So we go 30 times 2, which is 60, divided by 3 gives you 20. So this is 20 pi. And that makes sense because the whole circle's circumference would be 30 pi, that's this part here, and this part represents 20 pi. So that's the fraction of the circle's circumference. Again, you're just following the formula. Last part is the area of a circle and the area of a sector of the circle. Area of a circle formula is pi r squared. So you have to have a radius to do it with this. You cannot use diameter. So if we have a diameter here, I have to cut it in half to get the radius. So then to find the area, I'm going to go pi times 7 squared, which leaves me with 49 pi. And then I would label it as feet squared. That's the exact answer. If I want the 2 decimal place approximation, I'm going to type in 49 pi, and that tells me the area is 153.94. So that's my area. This one, I want to find the radius, and I'm given the area. So my area is 83 square meters. That is the same as pi r squared. So let's see, what could we do here? We could divide both sides by pi. It's going to be a crazy answer. So we get 83 over pi equals r squared. And then we would take the square root to get rid of that squared. So my exact answer would be the square root of 83 divided by pi. But if I would do an answer, the 2 decimal, whatever, approximation, 83 divided by pi and then square rooted, you get 5.14 meters is my radius. So again, we're just following the formula, that's all. Now this one's area of a sector. So instead of finding the whole area of a circle, we just want to find the area of a little section. And all you do there is you take the area formula, this is the area of a circle, and you multiply by the arc measure over 360, so the fraction. So for this area of a sector, I have my radius here. I would take the 72, the arc measure, over 360, and I would multiply it by 15 squared times pi. 72 over 360 gives me a fraction of 1/5. 15 squared is 225. And I bet you that 225 divides by 5 real evenly. Remember, multiplying by 1/5 is the same as dividing by 5. So my final answer for area of a sector is 45 pi. If I want the exact answer, I multiply by pi in my calculator and I get 141.37 centimeters squared. That's the area of that section. So I hope this is helpful. I highly suggest going through this, writing stuff down. Yeah, you don't need, this is only if you couldn't be here, email me a summary, but yeah, let me know if you guys need help. I'm here to help. Bye. I hope this worked this way.